Hi. So now we're going to talk about laws of exponents. And before we were multiplying, now we're going to be dividing. Don't panic. There we go. So before I even start, I have this blank screen because I want to just kind of explain something, right? Exponents mean that that thing is being multiplied like that number of times, right? So x to the second power means x times x. X to the ninth power is x times x times x times x times x 9 times, right? So now if we have x to, I don't know, the fifth power over x to the second power, that means 1, 2, 3, 4, 5. That means that, right? So you can actually cancel stuff. Those cancel, and you're left with 1, 2, 3 x's, x times x times x. So that's the same as x to the third over like nothing. There's nothing there, so it's just straight up x to the third. So the quick trick is look at your variables now and just subtract them. And that's that, right? So it gets a little weird. We're going to do more examples that'll help you, but let's do it the other way. What if it was x to the second power over x to the fifth? This changes things, right? Our bigger exponent is on the bottom. Let's see how this turns out. You got x times x over 1, 2, 3, 4, 5 of them. Cancel, 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 cancel. That means you have 3 x's left over in the denominator. So it's still like a subtraction problem, but where it lands is the issue, right? So you've got 3 x's left in the bottom, so that's where they go. You got x to the third, but what do we put on top? Well, you just use 1 as a placeholder, kind of. 1. So basically, wherever the exponent is bigger, that's like where the leftover ones live. So let's jump into actual stuff. Boom. All right, now this one has numbers in it. 2r over 2r. So this is the first problem from your actual assignment. So when you don't have any exponent, you want to put it right there. So that 2, there's nothing you could do with the big 2. It's just chilling. It's kind of just what's up. And then, look, you've got exponents 2 and 1. So any leftovers are going to be left in the denominator. 2 minus 1 is 1. So you've got r to the 1 kind of left in the denominator. And we neaten it up, and it's just 2 over r. And that's the ugliest square, but also the coolest. All right. So again, we got this 2 just kind of hanging out here. That's a 2. All right, now 3 minus 2 is 1, right? And the bigger exponent is in the numerator, so that's where the leftover is going to be. So you got that and really nothing below it. So once we clean that up, our final answer just kind of looks like 2x, and we don't have to write the 1. That's it. Part 3. All right. So we could put the 1 and 1 and be like, okay, 1 minus 1 is 0, which means there's exactly 0 r's, which means they both disappear. So that's one way to look at it. You could also look at this one just by saying, hey, those r's cancel out. Look at that. And then you've got this 3 in the denominator. So what goes up top? A 1. So your answer is just 1/3. Those r's are gone. Gonzo. All right, problem 4. Same thing. 2 minus 2 is 0. So we could do it like that, or we could just say, hey, like when you have same things, they cancel out. And you got 1/3. All right, good luck. I'll be in class to assist.